Hi there. So I haven't done a video in a while, and this might be kind of a weird topic to do this video about after not having done one for a while. But something touched my heart, and it really got me thinking about something that I feel like I need to put the message out there about, because I don't think I've ever talked about this before, but I feel like I really need to talk about it now. So I just finished reading a really thought-provoking book, okay? It's called Lifespan, and I have nothing negative to say about this book. Actually, the reason why I read it was because, after everything that I've been through, and you know my story, one of the things that's very important to me are birthdays and increasing lifespan, and the thought of how can I be here longer so that I can be with my family, my kids, and meet not only my grandchildren, but potentially my great grandchildren, and maybe even their children. So it's not completely unusual. For example, in my family, I have 3 living grandparents, and knock on wood, my oldest is over 100, and the other 2 are in their 90s. And I don't say this to brag. I don't say this because I, have great, phenomenal genes, whatever. They have great, phenomenal genes. What got passed down to me, we don't know. We do know that in my lifetime already, I have experienced a very serious illness, and it's been very meaningful to me, and it's kind of informed the rest of how I'm going to live the rest of my life, whatever that is. And I buy into the subscription that we're all here by God's grace every single day. So nobody knows what their timeline is going to look like. But by golly, while I'm here, I've made it my mission to make sure that other people don't have to suffer the same fate, and that their life can be just a little bit better. And quite frankly, I really buy into this fact that if I've made one person's life even slightly better, then I have done something good in this world. And I'm hoping that I've touched more than one life, and I'm hoping that I've made it more than slightly better. So that's why I have to talk about something that I read in this book. And by golly, 90% of this book, I was like, great, how do I get my hands on these products? How do I, what do I do? And granted, he talks a lot about the science and, what to do in terms of, like, if you want to increase your lifespan, right? And not just increasing lifespan, because it would be a complete tragedy if we increased people's lifespans, but not their health spans. In other words, if we allowed them or helped them to live longer, but we know that at the end of their life, people are sicker. That's when they're the sickest, right? Is at the end of their life. And so if we just increase their lifespan, the number of years that they're here, and we increased the number of years that they are suffering and sick, that would be ridiculous, okay? But what we're talking about is not only increasing their lifespan, let's just say, the median age in the United States of healthy year or whatever years of living is 80, okay? Probably the last 20 is spent sick in some way or another, or on some kind of medication. So how do we expand that lifespan not only to like 90 or 100 or beyond 100, but how do we also expand the years of health that people are able to enjoy their lives? Let's just say not just to 60, but let's just say that they're enjoying their lives until 95, and then the last few years is kind of not so great. There's a decline, and so he basically talks about in here why we age and why we don't have to. And like I said, I bought into, I was like the whole thing. I was like, let's go, right? I started researching some of the things that he talks about that he does, and he doesn't endorse any products or any supplements, but he does tell you what he does. And how that's made him feel so far. And he even talks about his father, who's in his 80s, and how that's made him feel, and what he's doing, and that he's able to travel, and basically behaves like a 50 or 60-year-old, which is, 20, 30 years younger than what his actual chronological age is. So when you look at all that and you think, okay, this is wonderful, but the thing that got me at the end of this book that just totally sparked a fire in me that said, okay, you have to talk about this, is that he really endorses genetically modified foods. And I hope that I'm not going to get on my soapbox here, but if I do, just please bear with me, because I do have a lot to say about this. And I've been silent for a really long time, even though I have been researching GMO foods for a really long time, over a decade. And GMO foods are, so like I said, it's the one thing that got me with this book that I part ways with him in this one area. So let's take a look at science just for a minute first, right? Just because you have scientist A that's doing really great, amazing work, okay, it doesn't mean that the scientist above him or below him in the same building is doing the same great, amazing work, okay? It means that they are going to work and they are each working on their own perspective science, okay? But it doesn't mean that their work is equivalent, that it's equally good, that it's equally beneficial. It might not be, right? And so we have to take that into consideration. Same with the scientist that's across the street or down the road or in another part of the country. We don't know what they're working on. We don't know if what they're working on is good or bad, okay? And we have to take each one of their work, okay, and look at it for its own entity, right? One by one. We can't just lump all science together and say all science is good. Can't lump all science together and say all science is bad, right? So we have to look at each individual case and say, okay, what is scientist A working on? Is this good or bad? And I recommend you read this book, because really we are at the cusp of some of these treatments and things that would help us live longer, supplements and whatnot. And so we're going to get there sooner than later. And we should really take a look at this and have some good conversations about this, right? We should. It's just necessary, because that's the way that we're going. Now that we've discovered some of these genes that would help us live longer, it is definitely worth a conversation. How long should we live? Is there, should we get to a point where we just say, okay, we're good, or, should we live forever? Or, do we want to live forever, right? And I think the reason why sometimes when people say, oh, I don't want to live that long, whatever that number is for each person, it's different, right? And I think the reason why they say that sometimes is because they don't want to have and live with all the diseases that come with living that long, right? All the deterioration. But what if you didn't have to? So let's talk about the GMO foods. Genetically modified. Some people call them frankenfoods. They are seeds that are genetically modified in a lab, okay, somewhere. What happens is everything has genetic information. You and I have genetic information. It's called DNA. And food also has DNA. It also has genetic information. Food is not something to play with willy-nilly, okay? Food is medicine. Food is information. And when you eat something, your body is informed, right? This molecule is going to act in this way. This molecule is going to act in that way. It's going to be either anti-inflammatory or it's going to be pro-inflammatory, right? And it's going to elicit a different response from your body depending on what you feed it. And genetically modified foods inform your body in different ways. So it's not something that we're used to, right? Sometimes, genetically modified food is labeled as natural. There's nothing natural about it, okay? It's created in a lab and it is grown in the ground like everything else. But some of the arguments that Mr. Sinclair argues for the use of GMO foods in his book have already been disproven. And I will get into that more. I will talk about that in just a second. So how do they make GMO foods? Maybe you don't know this, okay? So getting back to just food in general, the foods we eat provide us with vitamins and minerals that we need to be able to function, okay? Whether if you're eating protein, those proteins are broken down into the tiniest, smallest protein molecules, right? They're called amino acids. And it's like pieces of a puzzle, if you will, right? Where you eat it, this whole puzzle, right, gets broken down into tiny pieces, and then it gets reshuffled and put together in different ways inside your body, depending on, does it need protein A? Does it need protein B? Does it need protein C? What does your body need to be able to function and do what it needs to do? And the foods that we eat, whether they're conventionally grown or organically grown, or even if they're GMO foods, they speak to our bodies. They give it information about how to make proteins. What are the building blocks that you need? Or if you need energy, right? You need to have certain substrates. You need to have vitamins. You need to have minerals to make the Krebs cycle go and to create ATP, which is energy. So all of these things taken into account, right? Now we're talking about GMO foods. So like I said, this is like if you take the DNA of an apple and you take the DNA and you put it under a microscope, right? And then you say, well, I think we want to insert in here an apple that will never rot, okay? Like you'll slice it and it'll just stay white. It'll never rot. It will never turn brown. And so, you won't have to waste half an apple if you only eat half at a time. Just as an example. So what they do is they go to it could be another fruit, but it doesn't have to be. It could be anything. It could be a vegetable. It could be a bacteria. It could be a fungus. It could be anything. What these scientists are looking for are that piece of DNA that says, this thing doesn't rot. It's this little chunk of DNA that will not let this thing rot. It will never rot, right? Okay, so what they do then is they find that and they take it out of whatever and they kind of inject it into the DNA of the apple. And then so you have this brand new seed, okay? And you plant the apple tree and the apple, tree grows up and it, flowers and produces fruit. And now you have apples that are genetically modified, okay? So we're not talking about something that you can wash off because it's not on the apple. It's inside the apple. It's not something that you can cut away. It's not something that you can ever get rid of. And when you eat it, you get that piece of DNA also. You eat that. So what does that mean for you? Well, that's DNA that your body doesn't know because it's never had that. It doesn't know that it's supposed to do something with that. It doesn't understand this non-rotting DNA. That's not something that we're familiar with. We don't have problems with rotting, right? So injecting that DNA into a food creates a lot of problems. You don't know if it's getting right to the point where you want it to be. Because what happens is with our DNA and with all DNA is that it's read and it's transcribed, right? So if you've ever used a transcription service, you know that sometimes there are mistakes with letters, mistakes with words, and when you read through it afterwards, you say, I don't think that that's what was said, right? I don't remember that that's what was said. And so you start to think, well, what was really said, right? Or was that the meaning? Was that what they meant to say? And so it doesn't always make sense. And the same happens when that DNA is transcribed in our bodies. It doesn't make sense. Your body doesn't know what to do with it. And if a protein is made and it doesn't make sense and your body doesn't know what to do with it and it's not folded correctly, guess what? In the best scenario, it gets thrown away and your body tries to transcribe that DNA again, okay? And it tries to make another protein from that material. But if it keeps not working, sometimes it'll just keep on getting thrown away, and other times it will get written into different material, a different protein. Let's say the protein isn't completely misshapen. It's just kind of not quite the right shape, but not exactly like falling apart where it can't be used, okay? So in that sense, if it's not thrown away, right, then it may not produce the result that you were thinking you were going to get, right? Maybe instead of getting lots of good energy, you're only going to get half the amount of energy you thought you were going to get. Or, if you thought you were going to get a certain amount of substrate to be able to, drive a certain reaction in your body, maybe you're not going to have as much, right? How does that play out? What does that look like in your body? Well, maybe you need a certain amount of a molecule or a protein to be able to be calm. And if you don't have enough of it, then maybe what will result is anxiety. And what do we do when we have anxiety, right? Well, it depends on how much anxiety you have, right? Is it something that you can go for a walk or, go for a hike and you can relieve that anxiety? Can you do some self-care? Can you do, a warm bath and that will alleviate your anxiety? Or is it like through the roof and now you need medication for that anxiety? So different things happen when we consume GMO foods. And I'm just talking about the most basic examples here. How do we know that GMO foods don't work? Mr. Sinclair really advocates that we should just get used to the fact that we're going to have to rely on GMO foods because GMO foods is the wave of the future, and it's just the way that it's going to have to be if we're going to support a planet of 20 billion people. Well, we should start with the fact that, should we have 20 billion people? Can we support 20 billion people? And what's the best way to do it? So there's a lot of questions before we just jump to there's going to be 20 billion people on the planet. Maybe there will be, and maybe we'll decide that we want to do farming differently. Maybe we'll decide that we, want to grow things differently at that time. Maybe we'll have a lot of hydroponic foods at that point. Maybe that technology will be better at that point. We don't know. There's a lot of factors here, but to say that we just absolutely have to rely on genetically modified foods to feed all those 20 billion people is ridiculous. And it really struck a nerve with me. Because here's the thing. We don't really know why we have as much cancer in the world that we currently have. And especially in one of the wealthiest, richest nations in the world, right? We spend 17% of our gross domestic product, GDP, on healthcare. And yet, we're one of the sickest nations, right? Our health is not the best, okay? Our people are not the healthiest, despite how much money we spend on healthcare. So, GMO foods, I don't think that that's the way to go. I don't think so. And, like I said, we're not really sure why we have the cancer we have, or the numbers of cancer that we have. Maybe one of those reasons is what's sprayed on our food, the toxins, the pesticides, fungicides, herbicides, right? That could be a reason why. Maybe it's the toxins in our air and in our water. That could be another reason why. But maybe it's the foods that we're eating. that's grown in the soil, that's depleted of the vitamins and minerals that would normally go into that food that then we would eat and we would get. We know that our soil is depleted. That's not a contested piece of information. You can go online on pubmed.gov and you can find that information. You can find all these studies on pubmed.gov. Some of them are free and you can download them and read them, and other ones, some journals don't just put their information out there for free, so they make you buy their studies, and sometimes they're quite pricey. But there's plenty of stuff out there that is free that you could read, and so that's a good place to start. Why am I not a fan of GMOs? Well, for one thing, there's this book, Genetic Roulette, which is just study after study after study of how GMO foods have missed the mark. One of the things that, I guess I should say Dr. Sinclair, since he's a PhD. One of the things that Dr. Sinclair suggests is that GMO foods produce more yield, and that is absolutely not true. So another book, and it's also not a contested piece of information, another book that is really good that I highly recommend is called Seeds of Deception. And let's see, is it in this book? Oh, maybe it's in this book. So why GMO crops are not needed to feed the world. Okay, I just want to point out a few pieces of information. After you're done listening to this, or maybe you maybe already finished listening to this and you thought, okay, I'm just gonna go, figure this out on my own, which is fine, but I highly suggest that you go do some more digging on this. GMO crops are not necessarily safe. We don't know. They don't produce higher yields. They're not consistent and they're not reliable yields. So one year you could get a really good yield, and another year, the next year, you might not get as good of a yield. They're better than competing options. I don't know how GMO foods would be better than either conventionally grown food or organically grown food. And if people really did believe that GMO foods were safe and better for us, there would not be this whole movement to, for example, have non-GMO verified foods, right? Like, why would that be such a big deal to people if it was safe and good and wonderful, right? I don't know about you, but like, I know for myself, I have bought unwittingly, unknowingly, GMO strawberries, right? Conventionally grown GMO strawberries. On the outside, it's red, kind of orangey red looking. And when you bite into it or slice it, it is white. Strawberries are not white. Strawberries are red. And if you buy the container of strawberries that's GMO, they can literally last for 30 days or more in your refrigerator. And when I started thinking about this was probably a decade ago, and I remember saying to my husband, why would a strawberry last for 30 days in your refrigerator? Why wouldn't it grow mold and get disgusting and have to be thrown away after maybe a week or less than a week? And when we started really paying attention and buying organic strawberries, we noticed that organic strawberries really don't last more than 3 or 4 days. They're not supposed to. Let me alleviate that stress on you, right? Foods that are natural, the way that nature intended, not a lab, not a scientist in a lab, okay? They spoil. They're supposed to. That's just how nature intended. But GMO foods don't spoil. So maybe that's what Dr. Sinclair had in mind, is that if we have food that doesn't spoil, then it lasts longer and potentially we can feed more people, but it's not equivalent to normal natural food as nature intended. I'm going to try to separate those two things for you. Okay, so GMO foods that are created in a lab, okay, are not equivalent to foods as nature intended. Okay. There's an article, there's like so many articles in here. I mean, so many articles in here. Let me just flip through this book for you. So very many articles in here, article after article about why you shouldn't eat GMO foods. And these are not commentary, these are articles that you can search for on pubmed.gov. And I've mentioned that several times now, but it's a database where you can go and search and find articles that have been published by researchers, people like Dr. Sinclair. So here's one that talks about Bt genes. These are bacterial genes that have been inserted into corn that produces toxin in your gut. And actually what it's really supposed to do out in the field is to keep bugs from attacking corn and eating it and ruining it right before it even gets to market. So they came up with this way to make corn less susceptible to bugs. And what happens is the bugs land on the corn, take a bite, this gene gets into the GI tract of the bug and rips it apart. And the bug dies. Well, it's doing the same thing in our gut, right? So when we ingest that corn, then it is creating those ripped apart areas in our gut. And what many believe to be the case is that our gut has a lining that is literally, if you think about tiles, it is one tile thick, okay? These tiles are joined together by tight junctions is what it's called. Very creative name. Actually, it serves a purpose. It's very clear. Tight junctions hold those little tiles close together. Nothing permeates the gut that's not supposed to. When you eat foods that have these toxins, that produce these toxins within you, what you get is separation. And now things that are not supposed to get through that barrier, they get through. And you might be thinking, well, so what? Well, so what is that when a larger molecule is absorbed into the bloodstream that your body doesn't recognize, your body attacks it because it says, I don't know what this is. It's not a single amino acid that I recognize. It's not a vitamin. It's not a mineral. It's this conglomerate thing that I have no idea what it is, and I'm going to attack it. And what happens is, what results is food sensitivities and food allergies. Again, not contested. You can read about this. So this particular article is talking about how these Bt genes, once they're consumed, could turn our gut bacteria into living pesticide factories, which means your gut could then just start producing, your cells, your very own cells could be hijacked by this bacteria and just create more and more bacterial DNA within you, okay? That's another thing that you really don't want. This book, exceptional. Just some things that I wanted to point out from in here as well. Again, Bacillus thuringiensis, that's the Bt toxin that's in corn and cottonseed and canola oil. It's consumed by us, right? We consume these things knowingly or unknowingly, and we don't know that it's safe at any level for us to consume. One researcher found that rats that were fed GM potatoes suffered damaged immune systems. Again, going back to what is it that confers health and helps us stay healthy, right? Our immune system. So if we're poisoning our immune system, obviously we can't be healthy. GM fed rats had smaller, less developed brains, livers, and testicles. Researchers at Cornell announced that monarch butterflies died when they came in contact with pollen from corn engineered to create its own pesticide. That's with that Bt toxin, right? So that's what that Bt, that Bacillus thuringiensis, right? That's what that toxin does. It creates the toxin from within that corn, which means you can't wash it off. And it's meant to keep bugs away. So let's just talk about what I just read here. So, because I want to stop for a minute and talk about that, because that is something that Dr. Sinclair talked about as well. So, bees also die when they come in contact with these GMO foods. And bees are what create food, whether you know this or not, okay? There is no food without bees. They pollinate everything. They create food, okay? And there is a city in China, I've forgotten the name of it, where they don't have bees. They've grown so many GM crops and pesticides and used so many things that bees can't survive in that place anymore. And if you've never seen anything so ridiculous, people have taken over the jobs of bees because we have to have food. Literally what they're doing is standing on ladders like this, pollinating every single flower. Okay, they're just like, they have like a little brush in their hand, which is what normally a bee would do, but they don't have them anymore. So now they have people doing that. What he mentioned in the book was that the European Union banned GMO foods and some of these chemicals that were sprayed on the foods because farmers in Europe, various places, various countries, started to notice that their bee population was dying off by the millions of bees. And by the way, it's a problem that we have here in the US, but the European Union decided, we don't want these products, we don't want these seeds, and we don't want these chemicals, okay? Because we're seeing a problem. And what he mentions in the book is that, well, because they're doing it because they economically want to hurt the US. You know, I really don't think that's true, because our products are exported all over the world, and I don't think that an entire government or sets of governments, as it would be in the European Union, since these countries have joined a union, I don't think that they have gotten together and secretly in a room and said, oh, we're just gonna get back at that US, they're just horrible over there. No, that's not how it works. So they saw that their bee populations were dying off, and they said, we need to do something, and we need to do something quickly. And we noticed that this started happening after we started using these products. So we don't want these products. And you know what? That is their prerogative to say. And I will tell you what else. We noticed these problems right here in the US. We noticed them. Bees are dying. We know that. And we know what it's from. But in the US, it's a little bit backwards. See, our farmers and beekeepers have to prove that it is these toxins and these pesticides and these herbicides are the thing that is killing the bees. Not that the companies have to prove that their products are safe, right? No, they can just go out there and start using these products. And when we notice that there's problems, we have to let that problem go on for years and years and decades. And we have to accumulate evidence to say, this is what's causing the bees to die. And you know what? By the time that we accumulate enough evidence, okay, like the bees could all be dead by then. And us too. Speaking of lifespan and health span, right? If we have no food, we have no lifespan, okay? Last time I checked, humans eat at least, I don't know, once a day, sometimes twice a day. The, people who, really like to eat and have no problems with food insecurity get to eat 3 times a day and have snacks too. But I digress, okay? The point is that the companies that are putting out these toxins, it's not on them. They don't shoulder the responsibility to show that these chemicals are safe. Oh no. It's on the people that are poisoned and the animals that have no voices, so the people who stand up for those animals and speak for those animals, that have to turn around and say, here is decades worth of evidence that these chemicals are poisoning us. I find something inherently wrong with that, okay? And I found something inherently wrong in Dr. Sinclair's argument of that as well. And like I said, I'm not looking to pick any fights, but what I'm trying to say is, please go out there and do this research for yourself, okay? Please go out there, and before you just start saying, okay, GMO foods are the best thing since sliced bread, please do some research and decide for yourself if that's really something that you want to do, especially if you're a cancer survivor. I don't advocate for GMO foods ever, okay, quite frankly. I will say that organic is the best and conventional after that, and it really doesn't matter if it's fresh or frozen. I would say that canned foods really, the problem with canned foods is that all the enzymes have been taken out of them, and so nutritional value, something that can sit on your shelf for 2-3 years doesn't have much nutritional value. So that is a problem, a whole different problem that we can do another video about. But for right now, we're talking about GMO foods. And I would say that, as a dietitian, I would advocate for organic foods as much as possible. Fresh, of course, frozen if need be, because it can last longer. And it usually is frozen right after it's picked, so all the nutritional values retained in the food. If you can't buy everything organic, then buy certain things conventionally grown, but know that you're making that trade-off, and know which foods are okay to buy conventionally grown and which ones are better to buy organic. Now, I will be honest with you, I can't afford to buy everything organic, right? It's really expensive, and I have a family of 4 to feed. So, it's not always affordable, right, to buy everything organic, but I will tell you, I'd rather spend my money at the grocery store than at the doctor. So I hope that this has helped you in some way. I hope that, if anything, it's at least given you food for thought. And of course, you're free to make your own decisions, but hopefully I've given you some things to think about and go out and research. One last point that I'd like to make here is, while you're doing your research, while you are reading those studies, keep in mind a couple of things. Who did the study? Who paid for the study? How long was the study? How many participants in the study? What happens sometimes is, it's fair, it's not fair, whatever it is, it takes a lot of money to do these studies, and researchers and universities don't have the money to do it themselves, or they're not really even interested in the project, but the company who creates the chemicals is interested. And so they'll put up the money to do the study, but they have parameters on how they want the study to be done. And of course, they want the outcome of the study to be. So sometimes, for example, it's a short study, 30, 60, 90 days, and you don't see the evidence of damage or harm done because maybe it doesn't take effect until 120 days, right? Or 180 days. Whatever that time frame is, if the study isn't long enough, then you're not going to see any kind of damage that's done. So you have to pay attention to who's doing the study, who's paying for the study, how long has the study been going on, how many participants were in the study. So maybe they randomly, luck, got a bunch of people whose genetics were like, okay, they're not going to have a problem with this chemical. And maybe they missed out on the, rest of the population, or people who did have problems with it. Or maybe they actually cut them out of the study. So sometimes what happens is, people have a reaction and then they're the outlier and they get cut out of the study because they ruin the results. So just some things to keep in mind while you are doing your research.